Alrighty, so we are going to graph these. Now, there are many ways to teach students how to do transformations, okay? And some teachers prefer to teach it by putting everything in a T-chart, coming up with points all the time. I do not believe that that is the best way in my heart of hearts because you don't always know which points to pick, right? So I think understanding the transformations and doing it that way is really kind of the best because when it comes right down to it, yes, on a classroom test you might have to graph them, but when you're applying this stuff or you're in your higher level maths, you're not really graphing this all the time. You just need to understand where the graph went and what happened to it. So I want to make sure that you know how to do it my way. And it's not just my way, but, you know, I mean, we could have arguments amongst different teachers on how they think it's best. But all right, so the first thing we're going to do here, we have 2 to the x plus 5 power. So this is not just the parent function. It has a transformation in it. So we are going to write down the parent function first. So that would be f of x equals 2 to the x. Do we agree with that? Yes? Okay. And then would this be exponential growth or decay? Growth, okay? So then I'm just going to draw myself a little picture of what I know the parent function is supposed to look like so I don't do something weird. Then, even though I just said I'm not a big fan of the T-chart, I wouldn't, and again, I don't know where everybody's level is on everything. So we're going to do the exact same T-chart we did yesterday, which is not the points we're actually plotting. We're going to do it based on the parent function, and I think that just might help us get everything lined up here. So here's what I mean by that. Here's my x, and here's my f of x. And we are going to choose every single time -1, 0, and 1. So parent function, I'm not plugging it into the original thing. 2 to the -1 power is what? 1/2. 2 to the 0 power is 1. 2 to the first power is 2. When it comes right down to it, you don't even necessarily have to write that down, but I do think, especially with exponential, sometimes it's best to have it in front of you instead of just trying to think through it as you do it, because, I don't know, sometimes I'm like, I know what that is, and then I forget the number, but that's probably just me. All right, then the next thing we're going to do is list out our transformations. How many transformations does this original function have? 1. And so I have this x plus 5. That plus 5 means my function does what? Goes where? Is it up, down, left, or right, first of all? First of all, is it horizontal or vertical, I guess is what I should ask. Horizontal, because it affects the x, right? And since it's plus 5, which direction do we go, left or right? Left, because x is what? A liar, right? So we're going to go left 5. If you want to write the word left, that's totally fine too. I feel like nobody's asking me for the answer, so I'm kind of doing it for myself. So here's the way I would do this. I would start with, I'm going to pretend like I'm going to actually plot, and I might accidentally when I get too close to my board, but -1, 1/2. So I'm going to put my pencil, you can put your pencil down at -1, 1/2. And then from there, you're just going to go to the left 5. 1, 2, 3, 4. Oh, see, I knew I was going to do that. 5. Okay. Does that make sense? Then we go to the next one, 0, 1. Put your pencil down, but don't make a point, and then go to the left 5. 1, 2, 3, 4, 5. And then you go to 1, 2, put your pencil down, and move to the left 5. 1, 2, 3, 4, 5. That make sense? Now, we moved left and right. Does the exponential functions, do they have asymptotes? Yes or no? Yes. Is it horizontal or vertical? Horizontal. So if I have a horizontal asymptote, the only thing that's going to affect where it is if I move up or down. I didn't move up or down. I just moved left and right. So then my asymptote is still right here at y equals 0. And I can graph that. Something like that. Okay. Easy enough? You're basically just going to start with what I call your anchor points, because this is from the parent function, and then you just do whatever the transformations are. Now, as we get more, we'll talk about what order they have to be in. But by moving this to the left, did it affect the domain at all? It didn't. It's still all real numbers, right? Which is negative infinity to infinity. It also didn't affect the range, which is still 0 to infinity. Never include the infinities. I'm not including 0 because I have an asymptote there, even though my graph isn't perfect and it looks like it intersects it. Okay, again, not an art class. We're making the best effort and we're good. All right, so as x approaches infinity, what is y approaching? As x gets bigger and bigger and bigger, f of x is approaching what? What's it getting to? Infinity, thank you. And as x is approaching negative infinity, what are your y values approaching? 0. Now, what was affected was my y-intercept, right? It got, what was my y-intercept would have been 0, 1. It got moved to the left 5. Now, even if I had sketched this and like I had crossed my function like right there, I wouldn't get to guess off of my graph, right? But we have to remember what we know because we've done y-intercepts forever. The y-intercept occurs when what? What is 0 when we have a y-intercept? X. So basically what I need is f of 0. And in this case, I do need to use my original one. Otherwise, I'm going to get this answer. That's not what I'm looking for. F of 0, this is going to be 2 to the 0 plus 5 power. What is 0 plus 5? 5, good. So it's 2 to the 5th, which we can do. And if I do 2 to the 5th, I count on my fingers to make sure I do them all, right? So 2 times 2 is 4, 8, 16. 16 times 2 is what? 32. So this is 32, which means my y-intercept is at 0, 32, and that's why I don't see it on my graph. And again, just because we just moved left, our asymptote didn't change, and we get y equals 0. Okay, easy enough? We're not doing any crazy transformations here, for sure. All right, so let's look at any questions. I'm sorry. We're all good? All right, so my parent function, f of x, is equal to, what's my parent function? 1/3 to the x. Do we agree with that? 1/3 to the x power. Is that exponential growth or decay? Decay. So it would look something like this. I'm going to make my little t-chart here so that I have the numbers in front of me and don't make up math anywhere. -1, 0, 1. What is 1/3 to the -1 power? 3. Good, because it does the flippy thing, right? Right? 1/3 to the 0 power? 1. 1/3 to the first power? 1/3. How many transformations do we have? 1. And what is this one transformation going to do? Make my graph do? Down 2. Okay. Now, is that going to affect my asymptote? Yes, because the whole thing goes down. So what I would suggest you do is to actually go and draw in that asymptote so we don't mess things up when we try to sketch things. And I can go ahead and put the answer. It's y equals -2. Now I am going to plot my points same kind of way. But I put my pencil at -1, 3. So -1, 1, 2, 3. And then from there, I'm going to do what? I'm going to do this, which is go down 2. So I'm going to put my pencil here, -1, 3, and go down 1, 2, and that's where my new point lives. Then I put my pencil at 0, 1, move it down 2. That's where that one is. Then 1, 1/3, move down 2. That's about right there. Everybody understand the concept there? And we're not having to make all these T-charts with crazy numbers and do all that. So, sketch that in. All right, my domain is the same, -infinity to infinity. Did my range change? It did, right? Where do we start now? -2, good. So I start at -2, and I'm going to infinity. Do I include -2? No, I do not. All right, in behavior, as x is approaching infinity, what is y approaching? As x gets bigger and bigger and bigger, y is approaching that asymptote, which is now at -2. And then as x goes to -infinity this way, our y's are increasing without bound, which makes them go to infinity. Now, am I going to have to calculate anything for my y-intercept? No, because I'm not guessing off the graph because I plotted the point. If I just happen to intersect it, then who knows how accurate my graph is. But this ordered pair would be at 0, what? -1. We good? All right, now let's put a couple things together here. Can I multiply this 1/2 times the 3 and get 3/2? No, absolutely not, because that 3 has an x on it. You with me on that? All right. So my parent's function would be the part with the exponent, so it's 3 to the x. Is that growth or decay? Growth, okay. So this is growth, something like that. I'm going to make my little charts. Again, you wouldn't necessarily have to, but you need to know what the numbers are. Not a bad idea to write them down so you don't do anything weird. 3 to the -1 power, 1/3. 3 to the 0 power, 1. 3 to the first power, 3. How many transformations do we have? 2. Now, when you write them down so that you can do them correctly on your graph, always go from left to right, okay? Because really what happens is you can multiply and divide in whatever order, but you have to do the shifting left and right and up and down last. And if you go from left to right, that's going to happen. So we start with this 1/2. That 1/2 is what kind of transformation? First of all, is it vertical or horizontal? Vertical, okay? So it's vertical. And is it a stretch or compression? It's a compression because it's less than 1. Because remember, this is vertical, and that's y, and y doesn't lie. So it's 1/2. It's a vertical compression by 1/2. So that's the first one. And then the second one, this +1, what does that mean my graph does? It goes up 1, right? It goes up 1. Everybody understand what those are and why? All right, so is my asymptote going to be at y = 0, or does it change? Isn't this what affects my asymptote? So it's not going to be at y = 0. It's going to be at y = what? 1. Okay, so I'm just going to go ahead and put it in there. And I can go ahead and answer that part. All right, now your vertical compression. Vertical means, are we affecting x or y? Y. Very good. All right, so I'm going to plot these points, or I'm going to put my pencil at -1, 1/3. -1, 1/3. Okay? And then I have to do this vertical compression. That means my y value gets cut in half. What's half of 1/3? 1/6. Good, because it's like multiplying by 1/2, right? All right, so really, on a tiny little grid, whether you're at 1/3 or 1/6, can you really even tell? You can't. It's fine. So we're at -1, 1/3, or 1/6, and then I go up 1. So -1, and really it's just like barely above 1. But better than what I did, because I can't aim very well with this pencil. Everybody okay with that? Then I'm going to go to 0, 1. I take my y value, which is 1, multiply it by 1/2, and get what? 1/2. So I'm at 0, 1/2 now, and then I go up 1. Make my point. Then I'm going to go to 1, 3. What's half of 3? 1.5, right? So I can go to like 1.5, and then I move up 1, and I should be right about there. Y'all understand what I was doing there? Okay, just a little bit at a time to get the pieces that you need. And then I sketch that in there. Domain is the same. Negative infinity to infinity. Range, where am I starting? 1. Good, I'm going to infinity. As x approaches infinity, as x gets bigger and bigger and bigger, where is y heading? Infinity. As x approaches negative infinity, what is y approaching? 1. Yeah. Now, the y-intercept, do I need to, I don't need to calculate anything. I was here at 0, 1, right? I multiplied by 1/2, so I was at 1/2, and then I went up 1, so that's like 1 and 1/2, which would be 0, 3/2. 1.5 would probably be okay, but it bothers me. We good? I know, I just got myself doing that. I didn't even realize it that I did that. All right, what questions we got? We good? Yes, sir. Where did I get the 3/2? Okay, because I was trying to I could do it one of two ways. I could substitute 0 in here and come up with it that way, but I also just knew that when I plotted this point, I went to 0, 1, right? I multiplied it by 1/2, so that put me at 1/2, and then I went up 1, so basically I'm at 1 and 1/2, which is 3/2. Just kind of thought back through what I did. Okay, we good? What questions we got? All right. Let's do this one. We got 2 transformations here as well. All right. What is my parent function? 3/2 x. Yes. Is this or 3/2 to the x power, sorry. Is this exponential growth or decay? Sit up. Growth. Hey, y'all know why I'm doing this? Because y'all sucked at this stuff on these tests, so pay attention. All right. X and y. Then I have -1, 0, and 1. So 3/2 to the -1 power is 2/3. 3/2 to the 0 power is 1. 3/2 to the first power is 3/2. So if I did just like put points in there and I'd have all kinds of fractions all over the place. We just really have to deal with 3/2 and 2/3 and be able to count and be able to do this, and we'll be fine. I have 2 transformations, right? This -4 means my graph does what? Goes to the right, 4, good. And this 5 does what? Down 5? Yes? Okay. When y'all don't answer me, I can't tell if you're just like bored out of your mind or if you're clueless or what. So, all right. Now, is my asymptote going to be at y equals 0 or does it move? It moves. It goes down 5, so I'm going to put him in first. So that's at y equals -5. Then I'm going to plot my points. So I'm going to start at -1 2/3, which you just try, do your best there. But then from there, you're going to move to the right 4. 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. And I hit my board again. And my 2/3 kind of looks like 1/2, but you can control that better with your pencil. All right, everybody good with that? I go to 0, 1, move to the right 4. 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. And I'm basically right there. 1 3/2 is a little easier because that's like 1 and then the y value being 1.5. So I go to 1, 1.5, move to the right 4, 1, 2, 3, 4, and down 5, 1, 2, 3, 4, 5. And I can sketch that in. Domain doesn't change. -infinity to infinity. Range, where do we start? -5, good. Go to infinity. As x approaches infinity, what is y approaching? Everybody say it. Infinity, yes. As x approaches -infinity, what is y approaching? -5, thank you. Am I going to have to actually do something to find my y-intercept? Yes, it looks like I am. And I wrote real big, so I don't have a whole lot of room, but that's okay. So I'm going to find f of 0, which is 3/2, to the 0 minus 4 power, which is really to the negative 4 power, right? Minus 5. Now, I'm going to make you do this because I want you to think through it. Would you get a calculator for something like this? Yes, but let's talk about exponents and why we shouldn't be terrified of doing this stuff without one. This negative part of that 4, what's it going to do to that 3/2? Flip it. Very good. So this is really 2/3 to the 4th power minus 5. Do you agree that that's the same thing? Okay. When you take a fraction to an exponent, this is very important because it's also about how you put it in the calculator if you're using that. If you're going to put it in the calculator, depending on what kind of calculator you're in, the safest thing to do is put it in parentheses just like it is there, so you're not only taking a certain part of it to the exponent, all right? But that means I'm taking 2 to the 4th power and 3 to the 4th power. So 2 to the 4th power, so that means 2, 4, 8, 16, right? So 16 in the numerator. 3 to the 4th. 3 times 3 is 9. 9 times 3 is what? 27. 27 times 3 is 81. I'll just tell you so your brain doesn't explode. 81 minus 5. Now, is that going to give me 11 over 81? No, it does not. That makes no sense, right? Here's the other thing. When you take a fraction to an exponent, if you do it correctly, this will not reduce, so you don't even need to try it. Like, as long as this is reduced all the way to begin with, you wouldn't even have to try that. Like, you're not going to be able to because the factors aren't there. We'd have to get a what to subtract these? Common denominator. What would my common denominator be? 81. Okay, and so that I don't make anybody cry, I'm not going to make you do all that without a calculator. We'll just put as our y-intercept because it would still be legal. 0, 16 over 81 minus 5. Because the value's right. Would you ever actually put that as an answer? No, but I'm not going to wait and get calculators out and stuff. I don't think I have the answer in front of me. No, whoever did it did fractions. We good with that? Yes? Okay, awesome. So now I'm going to, well, how much room do I have? I guess I can extend my room. I will leave that there. All right, here's what I want you to do on 9. I want you to, without me talking you through it, I'll do it at the same time, write out what your parent function is, draw whether it's growth or decay, make your little T-chart, and write out what your transformations are. You've got 3 transformations here, so make sure you list them all out. And then to be safe when we are graphing, we want to make sure we do the transformations in order from left to right. When you're writing them out, if you realize you forgot one and you go put it back in there, then maybe you want to number them 1, 2, 3 or something like that. It doesn't matter. You don't have to like rewrite them. But so this negative sign means we reflect across the x-axis, right? And then this 2 means we have a vertical stretch by 2, and this 2 means we go to the right 2. We agree with all that? Okay, so will this affect my asymptote, or is it still at y equals 0? Y equals 0, good, because we didn't move up or down at all. So I'm going to go ahead and put that guy in there. This is at y equals 0. And since I'm reflecting across the x-axis, the sketch that we drew is of the parent function. So even though this is growth, when I reflect it down, it's going to look like decay, right? And so that's fine, okay? Or it's not going to look like decay. It's just going to look different, but that's okay because that's just our parent function. So we are going to, let's plot our points. So I'm going to go to -1, 1/4, which I know is kind of hard to estimate. We just do the best we can. The first thing that we're going to do is reflect across the x-axis. So now I'm just on the other side of the x-axis. Vertical stretch by 2. What's 1/4 times 2? 1/2. 1/4 times 2. Yeah, 1/4 times 2 is 1/2. Okay. So I'm really here at -1, like -1/4. Then I'm at -1/2, so I barely moved there. And then I move to the right 2, and I should be right about there. Okay. It's going to be easier to see exactly what I'm doing with the other numbers. I probably should have gone in backwards order. All right, so I'm going to go to 0, 1. I put my pencil there. I reflect across the x-axis, so now I'm here. Vertical stretch by 2. My y value is -1. I multiply by 2. Now I'm at -2. And then I move to the right 2, and I'm right there. Right there. Okay. Then I'm going to go to 1/4. This one will be a little bit easier to see. I'm up here, right here at 1/4. I'm going to reflect across the x-axis, which means now I'm at 1, -4, right? Vertical stretch by 2. -4 times 2 is -8. So now I'm here, and I move to the right 2, and my point is sort of right there. Oh my God. Whatever, close enough. That's the best I can do. And because we have a vertical stretch, it is a lot steeper. Like it gets steeper a whole lot faster, like so. Everybody okay with that? Do we understand the counting? How that works? I hope so. Okay, so then my domain, still -infinity to infinity. Where does my range start? Way down here. What's way down here? -infinity. Good. -infinity, I get to use all of the y values until I get to 0. Do I get to use 0? No, so it's open. As x approaches infinity, what is y approaching? -infinity. As x approaches -infinity, what is y approaching? 0, but from underneath this time, and that's okay. Y-intercept is not something that I have written there, so I need to find it. So I want f of 0. That is -2 times 4 to the -2 power. Can I multiply the -2 times the 4 to get -8? No. No. What is 4 to the -2 power? 1/16. Good, because 4 squared is 16, and then you take the reciprocal. So this is -2 times 1/16, which gives me -1/8. So my y-intercept is at 0, -1/8. Okay. What questions do you have? All right. Nothing, sure? All right, so then I want you, the rest of the time, you are going to be working on finishing that assignment that I gave you. I've been cheating and using somebody else's keys, but I don't like how she did this key at all. So I'm going to need to fix all that. But if you need me to check anything before you leave today, I'll check it, and then I'll have a key for you to actually look at tomorrow. Are we good? Make good use of your time. Stay off your phones.